So welcome to these impromptu Sage days. So this is the front page of SageMath.org, but it's best to proceed to GitHub. So a major achievement of beginning of this year was that we transitioned the Sage development from an integrated system to doing things on GitHub. And so that's where our starting point will be. So I'll walk you through on what to do to set up a working Sage on your computer. There are also some online options. I'll not touch on them today. So let's if you want to look at those, we have code spaces. That's an experimental feature. And there's also something called Gitpod that we worked on. However, we'll just do local things today. And so let's figure out how to do this. So I'll take us here to the code local tab. And what we can do is we can just grab the URL and so then I'll open a terminal. So this is from the perspective of a system that allows you to have a Unix terminal. So I'm here on macOS. The same works on Linux. If you're on Windows, then one has to go through WSL. We get Sage onto our computer. So let's say we have the directory demo, and what I need here is, of course, a Git. So I clone Git from clone Sage from this URL, and that gives me the source tree with history of Sage. So while this is doing that, let's take a little bit look at what we can see here on GitHub, and let's also simultaneously look at the documentation that is available on Sage. You'll find this on doc.sagemath.org. And documentation consists of several categories. So we have some tutorials, we have the reference manual, which is pretty large. And then we have the installation guide and the developer's guide. And so if you look at these documents, not too long ago, there are many changes that have been made since then. So let's take a look at the installation guide, and I'll show you my favorite parts. So I'm here on macOS, and so what this front page of the installation guide provides us is basically a decision tree on, what to do if, depending on what system you're on and what kinds of things you would like to do. And so there's basically a choice between whether you want to set up things for development or purely from the perspective of a Sage user. And so for Sage users, there are some options of getting binary builds. So for example, the 3 Manifolds project is providing a build of SageMath on macOS. CondaForge packages Sage, and there are also, if you're on Linux, you also have, depending on the distribution, various various distributions are packaging some version of Sage. It varies very much whether you're able to get something recent. So Arch is up to date. It's on 10. Debian and Ubuntu are slightly dated, so one cannot really recommend working with these versions. else have we got? Nix packages is up to date, and Void Linux is up to date. So if you are on one of the platforms where just an older version is packaged, I would recommend to instead go the Conda route, or to follow the instructions for developers, which are related to each other. So I'll show you the fastest route to getting a development environment. So let's see which way we can walk. We can go to this section, install from source code, and this tells us that in fact we entered the wrong place, and we should have looked in the README instead. So let's look at the README. So this is also something that we find in the root of what we just obtained here. So this has now downloaded everything, and so we see here there's the top level README, so we can also look at it here. Okay, so this walks us through on how to get started. So again, yeah, so this is for a situation where we already have a Unix terminal, Unix shell at your hand, and so on Windows. So Sage used to provide a build option to use Cygwin, and so this is no longer maintained at the moment. And so the way to run a Sage on Windows is to use WSL. And so this works on all modern computers and versions of Windows, so Windows 10 and 11. One may have to change some settings on virtualization options, but it works very smoothly. And so on macOS, there's a great architecture shift that happened. So it you might either be on the Apple Silicon platform if you bought a Mac recently, or you're on Intel, and so in both cases there are ways to install things going the homebrew way or going the Conda way. So today, for uniformity, I'm going to go the Conda route because it looks the same for macOS and Linux. Okay, and so then there are lots of instruction to build from source. So if you usually skip reading the README because all software packages are installed in the same way, namely using /configure make install, you will want to read this one here. So there are a few more steps, and the reason for that is that Sage is very big and contains many packages that can either be taken from the system, where system can mean lots of things. It can mean what comes from your OS distribution, or what may come from Conda. And the alternative is that Sage builds everything from scratch, and that's not the fastest way. So this is all configurable, and I'll walk you through. So we are somehow already in step one. So I've decided where to get my source directory situated. So we are here in the directory demo Sage. And so this is something that we refer to as the Sage root. And I think I have enough disk space and so on. I'm not on a network file system, so everything is good. Okay, we already did step two. We somehow cloned we somehow cloned things from the repository, and then let's do a little bit of Git practice here. Let's take a look at where we are. So various ways we can explore where we are. So Git status tells me I'm on origin develop. So what's origin? For that we type git remote -v, and so it tells me that origin is this. Okay, so let's make a change for uniformity here. Origin is something that we will later want to use in development. And so it's a good idea to rename this remote first. So we do git rename origin upstream. So upstream is the typical name that one git remote rename origin upstream. And now we have upstream pointing to the Git repository where we got our Sage. And so this is how we would refer to it when we are obtaining new versions through Git. Next, let's take a look. We will need required minimal build prerequisites, and somewhere it should tell us about doing things the Conda way. Install from Conda Forge. So on this page, install from Conda Forge, there are 3 options, and it matters which one we choose. So here in the first section, it's telling us how to use Conda to provide all of Sage. So this depends on the Conda maintainers of the Sage package to have packaged and kept in a good order the packaging of Sage. And so I'm not going to do this one right now. And the second section is the one that I'm going to show you, using Conda to provide system packages for the Sage distribution. So this means the following thing: we are using Conda, which is of course a huge software distribution, to install lots of packages that Sage can use. However, most of these packages are non-Python packages, and Sage is prepared to make use of those through a mechanism that I'll demonstrate in a second. Whereas Sage will build everything that it cannot make use of from source, and that includes most Python packages as well. So Sage does not have a mechanism to use system Python packages at the moment. However, there's a third option on this page. It's using Conda to provide all dependencies for the Sage library. This is still marked experimental. This is the super fast way of getting an environment that works on your computer, but I'll not do this one today. So let's do this middle one. And so it directs us to do this one here, bootstrap Conda. Let's do this. Let's forget about the README. So what bootstrap Conda is doing is it's creating from centralized information in the Sage source tree regarding packages, create some Conda specific files that are called environment files. So we can look at them. So we find them generated here. So environment.yml, that's the one that we want to look at. This one here is a larger one. So let's take a look at what's in there. Cat environment YML, and so it's just it's a very simple file format here that configures the channel. So Conda is a system that comes with many flavors. So we have original Anaconda, then we have variants such as BioConda, and there's Conda Forge, which is a huge community maintained repository of packages, and then there's the no defaults. It's configures how packages are handled, and so then it lists lots and lots of packages, and so let's use that to install stuff. So what we need is certainly some installation of Conda first. So I already have one on my computer, but if you don't, then here are instructions how to get this. So there are a number of flavors as well that are available. There's original Anaconda, then there's something called Mini Forge, and there's Mamba Forge, and so on. So Mamba is a fast version of the Conda package manager, and but in the end, all of them are equivalent after you do the configuration that is done for us, and so that's the starting point where we go. So you see, there's something that we can see here in the prompt. I already have some Conda around. Most of the days I just deactivate the Conda environment, but today I'm going to actually use it. And so let's follow the instructions. Let's create an environment based on this environment file. And environments in Conda can either have a place or a name, and let's use a distinguished name here. Let's call it today Sage Demo, Sage Days 120. Okay, and let's take a look. Meanwhile, let's take a look at the other documentation that we have. So go back to doc.sagemath.org, and we see the developer's guide that also has received recent renovation. Of course, because of our move to GitHub, that basically made half of the developer's guide outdated, and so this has all been updated to the current practices. So this assumes no familiarity with Git or with GitHub, and explains how to get started. So it tells you how to interact with other Sage developers on GitHub. Has some tutorials on working with Git, and then walks you through making contributions to Sage and so on. We'll take a look later. Let's see how this one here is going. Oh, it's still running. So it's still finite time. Okay, so let's take a look at the developer's guide where this is running, and let's look at the development walkthrough. And so, all right, we have already checked that we have a Git on our computer, so let's skip this. And so if it's the first time that you use Git as a contributor, then one needs to set up some identifying information. So that's done with these commands, and so these ones here just query. So let's take a look what it says for me. Okay, but one can use the command also to change this information, and so that's explained here in this section, configuring Git, how to do that. So we have already done this one here. This command line that is presented here is already one bit more clever than what I did when I showed it to you. it's doing this renaming of the remote repository name to upstream already as part of this command line. Not it's the end result is the same. So I did this one here already, went into Sage, well, this one here is I think was already on the development branch. Let's check this. So we can always find out where we are by typing git status, and so we are already on develop. So Sage uses basically just one branch, and that's the development branch. In Sage development, we have one release manager. That's a person, and the release manager merges approved pull requests. We'll get to that in small batches into the development branch after rigorous testing. Then when the batch has been merged, a new beta version is released. So Sage uses the word beta version in a slightly non-standard way. In Sage, there's no planning for features for a release. And so what's happening during the beta phase is simply that indiscriminately ready pull requests are merged, whether they are bug fixes or new features and so on. And then there's a very short stabilization phase after the first release candidate for a stable version has been created. Okay, so let's go through here. So here is some introduction to Git branches. So I can create a new branch if I want to make a change. So today I have the goal that I want to fix poor formatting and documentation. And so checkout -b is the command. It creates a new branch in Git, and it also switches to that branch. And so I have here in my Z shell, I have something that always informs me about the current branch. So it's appearing here in yellow. You can also configure something like this. Okay, so we want to make these changes to the documentation. And so I show you a little bit while Conda is doing stuff. So now it's in a new phase, it's downloading packages. So while it's doing that, I can walk you a little bit through the Sage source tree. So there's interesting stuff happening. So we have SRC. This is the part that most people will interact with. So, and in particular in source Sage, there's everything that forms the Sage library. And so it's organized in the mathematical geometry, quadratic forms, maybe on the mathematical side, and technical subdirectories like libs or CPython or ext as examples for the technical category. So, and then there's also source doc. And so this is where documentation lives. So that is documentation is maintained in RST format. So that's restructured text. So the reference manual is special. in the reference manual, we do have a number of, let's say, chapters, for example, for combinatorics and so on. And this contains a little bit, it contains an index, but the bulk of the documentation is coming from actually the source code. So what you see in here in Combinat index RST is really just a skeleton. And so this one here is then including a module list. So there's another thing that appears here, module list RST, and so this then lists the various modules that are found in the source tree, and that's all. The rest of the information is coming from files just like these ones here. So how about this one here? And so if we look for it in the source tree, so the Sage was already part of what I copied here, then we find there's a Python file that's defining this module. And so in order to build this documentation, the information that our doc building system needs is always contained in just strings. And so the strings are also using the restructured text markup format. All right, so this one was probably not such a good choice. So let's see, let's look for Combinat. This one here. So let's see a little bit more. So here's a title that will lead to the page title in the build documentation. And then we see there are documentation strings for the individual classes and methods and so on. And so these end up being formatted in the documentation as well. So let's relate this to the formatted documentation while Conda is still spinning here. And let's try to find this same thing over there in the reference guide, doc SageMath.org. And we have here the reference manual. And we said we found things in Combinat. And so what's the name of this file? It's affine permutation. Okay. So let's see. So let's see if we can search for it. Somewhere here should be a search bar. Yes. Okay, affine permutations. Okay, and there we go. And so if we look at where this is located in the URL, we see this one here is the chapter Combinat, and then we have something that corresponds to the name of the Python module where this is coming from. So we have sage.combinat.affine permutation. And so then you see all of the things that are written here. They are generated from the documentation strings, so we are now on the hunt for mistakes that we want to fix, and of course, since the documentation is in such a good shape, we will have a great trouble doing so. Except there's something that stands out here to me, and that is these strings here. They don't look like they're formatted right, because they should be they should be code strings. Yeah, so as input for the type here, we are supposed to pass the Python string decreasing, and so this formatting here is not giving this away. Okay, so let's fix this and then take a look at. So I'm opening my editor. So today I'm pretending that I'm a VS Code user and do this in VS Code. And so now it's a bit larger. So let's try to find the faulty markup somewhere here. So we saw it in two bounded partition. Okay, so let's ask for it. Okay, it is here, and there we see there are these strings, and they don't have the sufficient markup. Yeah? So in order to get them to have the right markup, I would have to put these quotation marks here. So it will in the end have 3 quotation marks. So 2 to mark things up as Python code, and then this one here because this is a Python string. Okay, so let's do this in all places that we see. And it's, of course, a very boring change, but we can do it. Okay, there we go. We save. And now I'm stopping to pretend that I use VS Code, and let's return to the command line and just look at the status now, what happened here. So Git knows that we modified this file, and so I can just commit this file and leave a small commit message. I can say here, yeah, so fix doc string markup, and the -a here means commit everything that's changed. Okay, and do git show, then we see here what this commit, so this change set here is looking like, and we have it here. Okay, so now let's suppose I didn't just do this for my own entertainment, but rather that I want to contribute this to Sage. Let's go through the procedure to do that. So what we will remember that I have here the git remote command that tells me what I'm connected to. And so here I have this upstream repository, and however, as a new developer in Sage, I cannot write there directly, right? So what I should be doing is first go to GitHub and create fork of the repository, and so okay, let's find a fresh browser window. I lost the one that I was working from, and so just to editorialize here a little bit regarding the word fork. So in the old days of open source or general software development, fork was a bit of a dirty word. So fork was something that if you create a fork of software, that means you are taking it into an incompatible direction from the original authors, or just you put it out of the control of the original authors. You maintain your own version and so on. So GitHub it has been one of the main drivers of change here. So forking is a normal mode of operation in contributing to software these days. So one creates a fork, and thanks to the development tools, so in particular Git, and on top of that, the system of GitHub pull requests, one is able to merge changes made in the forks back into the original repository if they are welcome there. And so it is no longer considered a hostile act to fork, but rather normal part of the development procedure. And so so you see here that since we created this new repository for Sage on GitHub in early February this year, we already have 190 forks, so 190 people who created forks of this repository, and so we can also, of course, I already have a fork under my control, but I could click on here again and create another fork. I'll not do this now. I already have enough of those, but this is where a first-time contributor for Sage on GitHub would go to create this fork. And so I'll now go to my existing fork, which is just my username /sage, so mcurper_sage, and so there's something happening here. It's a good idea to change the description a little bit so that people do not get confused that that this is not the authoritative version of Sage or anything. And so this is what I did here. Anyway, so this is where now where the origin of all my contribution activity is happening, and so I can just add this remote here. I now call this origin. That's, if you remember, that's what things were called before when I just did the fresh checkout. And I'm taking the URL that I find here. Copy. And now I can interact with this repository. In particular, I'm here on my branch, and what I can do is I can take this branch and push it over to my repository. And so the command that I recommend for that it goes like this. So this is assuming that I have chosen a meaningful branch name here, is to go git push -u. U means set upstream, and I do origin, which is the name of the remote. So I'm sending it to my repository, and then head is the name for the latest commit on the current branch. And so that's kind of the quickest way of getting done what I want to get done. So I do this, git push my origin head, and pushes stuff over there. And then, so yeah, oftentimes if we see lots of messages coming, we happy to ignore them, but here's some important and helpful information. We can create a pull request by just going to this URL. This is something that the remote repository is telling us. So there's a GitHub feature that tells us I just pushed a new branch, and so it's recommending that we now create a pull request. And so that's what the page looks like for opening a new pull request. So you see it picked already a name of, so a title for this pull request. It took it from my commit message that I made. And let's keep this for now. Everything can be edited later. There's something that I want to draw your attention to, and that's these fields here. So one can select where to send such a pull request. In the easiest setting, one just sends the pull request to the central repository. So that is SageMath Sage, but there are also other collaboration styles that are possible. So maybe you're collaborating with some friends on a more complicated contribution, more than just fixing the markup, and then you can also one of your friends can maybe maintain the main line of this feature that you're developing, and then you can send a pull request to the repository of that friend and that branch. Yeah, so here we are can also select a branch, and here one can select different repositories. Yeah, so here because GitHub knows about forks and forked of forks, it has here a catalog, and this is searchable as well. So you can find your colleague who has forked Sage, and so you can send a pull request there instead. But let's just send it to the base repository. So maybe this pull request is a little bit lightweight, but there's nothing wrong with it. It's easy to review, and let's just do that. Okay, yeah. So let's try to. So here's a template that we are asked to fill out, and so we'll just say basic RST formatting fix. Okay, so how about that? And yes, there's some check marks that we can fill in. So how does one fill in these check marks? Mark the space, type an X, and let's see. The description explains in detail what this PR is about. Well, in detail, I don't know, but maybe enough detail. And yeah, that's probably good enough. Okay. Oh yeah, here's one thing that I can do. I can assign this to myself, and okay, let's just create this pull request, and there we are. So this now appears as a PR, and so now things are happening automatically. If you're a first-time contributor via GitHub, these things might not run immediately because there's a confirmation step that the maintainers need to click once. But what's happening here is that some automated tests are running. So there are some fast tests and some slow tests. So what's fast is some basic linter operations, so checking for code style violations for code, and so here's also relint. It's another linter that uses regular expressions, so basic simple patterns that indicate some questionable things in the code, and then the kind of markup that we just fixed. There's also some basic validation that runs very quickly, much faster than building the Sage documentation, which can take pretty long. And so there's a quick check if I messed up the markup in a way that is not just like what I fixed, not nice enough, but syntactically problematic. Then this is something that would be catched. That would be something that would be indicated already in this step. And then we also have so this one here is a code style check, as I said, and so this one here is more interesting. This one is actually building Sage with this change, and it is something that will also run the tests, the documentation tests of Sage. So it does this not as a build from scratch, but rather it takes pre-built containers or a Docker image of the latest development version, and then builds incrementally with a new source tree on top of that. So it, in our case, we only touched one source file. So had this been a Python file, it would have compiled exactly that one, and not it wouldn't have to do anything at all if this were just a Python file. So okay, so it looks like we changed the Python file here, yeah, so it's not going to do anything. And after it finishes this, it also runs a couple of other checks. So Sage increasingly uses type annotations in Python, and so there's a sophisticated system called PyWrite that does static checking of such type annotations as well. Right now, it gives an insane number of errors, which is why this one is just an informative step. It doesn't issue real errors, but this is something that will be useful to change in Sage. That we get enough coverage by type annotations that the static checkers can give some meaningful reports. Okay, here's another thing that's happening at some point. Okay, so let's take a look. Something's happening here. Incremental build. So what does it do? It's doing something that we haven't even seen yet in our local operation. So let me switch back to the local operation, see what Conda has been doing. Okay, so here we go. Reminder, what did we do? We created an environment, and so it did something, and so it now tells us that we can activate this environment. Let's do that. This only takes so long because I need to buy a new computer. Okay, this will be instant on your computer, and so now we can check what this is. So if you type echo $conda, then we see there are various environment variables set. So for example, you can ask for the conda prefix. In this way, we can find out where, what do I need to delete if I want to get rid of this altogether. Yeah? So that will be this environment here. And so we can ask, yeah, so how much space is taken by that. Anyway, so let's not do this right now, but let's continue in the installation guide with the installation instructions. So remember, we came from the Conda installation guide, section 2, not this one here. Okay, so I just activated the Conda environment. Yeah, mine is named differently, not Sage build. And then we continue with these commands. So we do bootstrap. Oh, does this work? Oh, yeah. So this copy button removes the prompts. So you can actually do this. So do this and do. Oh, something went wrong here. Somehow we lost this one here. Okay. Like this one here, and okay, let's just keep it there. So what does Bootstrap do? It does some magic, so creating some files that need to be generated first from information that is in the source tree. So this will take a few seconds, certainly less than a minute, and after that, the configure script, so this is one of the files that is generated by this Bootstrap step, will run, and to configure is the step that checks for the suitability of system packages, so the ones that we installed now using Conda and possibly what it might find elsewhere in the system, and so that will run in a moment. So, but we were somewhere just a moment ago. Oh yeah, here. So let's take a look at what's happening here. So it's just did the Bootstrap as well, and it's also doing some configure like things. So this is not a from scratch run of a configure, but this is what is called a config status recheck step anyway. So this is what configuring looks like. It's checking for various details in the system. And so this one is all kind of a vanilla autoconf script, so not Sage specific up to the first line of dashes. This is where various Sage specific things are happening. This is where various packages are checked for their suitability. S package, so that means probably a Sage package. And so, for example, we luckily don't have to install the compiler because it found something suitable. And this is the GNU multiple precision library. So it runs a number of checks and everything looks good. So it's using that. Yeah, and so this one is running on a Linux, and so it finds these things in user include and so on. Looking good to it, so it's taking it, and so that goes through roughly alphabetically, except that there are dependencies between some things, and so it's in the end following that order. So this is going all the way to the end, and it will give a final report on what is installed and what is not installed. And so this is now truly alphabetically sorted, and so it's giving this report. Yeah, so what's happening here, and so here you can see the effect of this being not a from scratch build but an incremental build. It's reporting that certain packages are already installed. So that means Sage installed those already, whereas others they're listed as having been taken from the system, meaning whatever we installed in that container image using, in this case, this is running on an Ubuntu. So what was installed with apt-get in the Ubuntu. So, and finally, after all of this detail, it ends with some installation advice. So it's telling me, I mean, nobody is reading this, yeah, because this is just running automatically. It gives advice that certain packages could additionally be installed from the system using apt-get. So this is dependent on the package system that is on your computer. It will give specific information to that packaging system. So for Fedora, it's going to use Yum, and for OpenSUSE, it's going to use Zipper and so on. And so configure ends with saying it's creating a bunch of uninteresting files, and then the build step starts. I said this is an incremental build, so nothing is happening. That's almost true. There's some helper packages that are touched pretty often. So anyway, so this is now the Sage library that's being built, and yeah, so it's done with the installation already. Nothing really happened. There was no update, and so now it's running the test. So what this one is running is it said here sage -t -- new. So this is looking at the dirty files. So it's looking at the files that are changed compared to the Git index. Yeah, so we have changes that are not committed yet, and it's running those through our testing framework. So now you might wonder, why is it that it's running those after all we committed them? That's special magic that we are doing in this incremental build. We are marking those that are changed compared to the build of Sage in the container. We are marking those as dirty, and in this way, everything that hasn't been tested yet in the build of the beta version is going to be tested here. Okay, and then there's a step that's called build and test modularized distribution. What's that? If you want to know about modularization, I'm going to explain some of this later in the afternoon. And so that is built into our test processes here as well. And then, all right, yeah, so there's pywrite checks, and so this is working really hard. And when this is done, this will actually run a test for all files. So to make sure that really all tests, including tests that are marked as long time, are going to be tested. And then it's running some coverage stuff and so on. Okay, yeah, so so that's what helps us with checking automatically that proposed changes kind of pass tests. So to review a pull request, one does not necessarily have to check out that branch and build it yourself, because the system is doing that. Okay, so let's see if this one, okay, yeah, this is now in the middle of configure. This will take a while, and so this is where I stop for now. Yeah, so you've seen the full cycle of taking Sage current development version from the GitHub repository. We brought to our computer, we created a fork, and we committed a change and created pull request from that. And now it's just a matter of doing that for the things that you're interested in. I'll stop, and I'll be happy to take questions